Hello. Today we're going over some functions, so let's get right into it. We have our first question. The function f of x is equal to 5 plus 3 cosine 1/2 x is defined for 0 as less than or equal to x, which is less than or equal to 2 pi. This is just our domain of the question, so I'll make a little note right there. That's our domain. And our first part says to solve the equation that f of x is equal to 7. Give your answer correct at 2 decimal places. So what we are going to do is we're going to take f of x and make it equal to 7, like it says. So 5 plus 3 cosine 1/2 x. We set that equal to 7. You can do it on the left side, right side doesn't matter. I'm just going to put it on the right side because I feel more comfortable with that. Then first we're going to start with the outside and move on in. I'm going to subtract 5 on both sides. So we have 3 cosine 1/2 x. So minus 5 on both sides, that would be 2 on that right side. Then I'm going to divide by 3 on both sides. So cosine 1/2 x equals 2 over 3. Then I'm going to take the inverse cosine on both sides. So the inverse cosine on both sides, I don't have to write it really over here. I just have 1/2 x remaining, and the inverse cosine of 2 over 3. So we grab our handy dandy calculator, make sure it's in radians as that's what the domain is in. And we press the inverse cosine of 2 over 3. And we get 0.841. Of course, when we do our calculations, we'll use the full number, but as for the moment, we can just write a few digits down, AICE exam, they don't really get at you for writing 9 numbers. 9 numbers, 3 numbers, they start viewed as the same. And then we need to multiply it on 2 on both sides to get rid of that 1/2. So x equals 1.68. And that, of course, is sort of our rounded answer. And I want to make a note for anyone watching that if you're sort of a new student to AICE Math, don't worry if you don't entirely understand cosine of all those functions yet. You go more into depth on it on Chapter 4, Chapter 5. But right now, this is sort of just plug it into your calculator, so relatively, getting this first answer isn't too hard of a thing to do. But for the second answer, it can be a little difficult if you aren't used to the material. So, let me get my pen back up. So, we have something that we call all seniors turn crazy. All students trust Cambridge, all students take calculus, whatever you'd like. But what this means is it talks about which operations are going to be positive in which quadrants. For example, in the first quadrant right there, all functions are going to be positive: sine, cosine, tangent, etc. While on the other hand, in the second quadrant, only sine is positive. That's why we have the S. The S stands for sine. In the third quadrant, tangent is positive. And the fourth quadrant, cosine is positive. And we see that in tangent, the reason why only tangent is positive in this quadrant is because sine is negative, cosine is negative, sine over cosine equals tangent, negative over negative equals positive, right? So with this, we're going to start looking for our second answer that we could have. We see that we have the cosine of -1 over of 2/3 is 0.841. We're going to label our axes. This is 0. This is pi over 2. This is not 3, this is pi. This is 3 pi over 2 right there. And our 0.841, if pi is 3, and then pi over 2 would be 1.5, we see how this 0.841 would fall right about there. It's sort of chilling. And in order to figure out where our other answer is, we think about what our quadrants are. Cosine is, we're taking the cosine of a positive number. So it's going to be in this other quadrant where cosine is positive. Cosine is positive in the first quadrant and the fourth quadrant, whereas all of them are positive and only cosine is positive. So our angle should be around there, and we're going to go from the x-axis. We're going to take distance from there to there, distance from there to there. So the way we do this is we say, okay, 0.841 minus 0 is going to be 0.841. Then we're going to take 2 pi, which is also right here, and do minus 0.841. So in our calculator, 2 pi minus 0.841, we'd get 5.44 roundabout. So we'd have 1/2 x equals 5.44. So we need to multiply by 2 on both sides. And that would be 10 point, I'm going to round that to 9. And we see that if you put 2 pi in your calculator and turn that into a decimal, 2 pi is about equal to 6.28. And our domain goes to a max of 2 pi, or 6.28. So we see the second answer, that 10 is also 10.9, would not fit into this. So that is not one of our answers. We only have x equals 1.68 as our answer. Next, we have to sketch the graph y equals f of x. So we're going to start by drawing our axes, right? That. And this domain that we have is in radians, so I'm going to do that for the x's. We have pi over 2. We have pi, 3 pi over 2. Try to make these about equal in distance. Doesn't matter if they're perfect, they just have to be relatively equal. Then we have 5 plus 3 cosine 1 half x. Let's start breaking parts this down. There we go. I'm giving us just like a little bit more room to work with. So each of these different numbers are going to mean a different thing. Right now it's not really equal to 7 our function. We just have the function of this in general. So I'm going to start with what's with the x, guys. There's only one thing right there. When we have a number that's being multiplied with the x, we call that a horizontal stretch. And what this stretch is doing is it's affecting how, I want to say how slowly or quickly the things move along the x-axis. So what a 1/2 means is it's moving 1/2 as fast. So a normal sine graph would go to 1, -1. Then we have our 4 notches at the bottom. It would start at 0, and 1 that's normal, so it's just a sine of x, would go up to the 1, go to 0, down -1, and back to 0. On the other hand, if you have a sine of 1/2 x, with the 1 and -1 right there, we always assume if it's 1 if they don't put a number, because anything times 1 is itself. So if we have 1/2 x, it's going to move half as quickly. So we're going to have it start at 0, it goes up to 1 by the time that's supposed to reach 0, then it's going to go back down slowly back to 0. And if we continue this graph longer, we would see it eventually goes back to -1, eventually goes back to 0. This graph is twice as long. It goes half as slow. That's why we have the 1/2 there. And also, if you were interested, 1, 2, 3, 4, up to 1, -1. Sine of 2x would move 2 times as quickly. So in this span that it would go from 0 to 1, it would go from 0 to 0 again. So that sort of looked like whoop, whoop, just like this. Like that. So we see how it goes 2 times as quickly versus 1/2 as quickly. And in this case, we have 1/2. So this is partially what our graph should be looking like. So now erase that. I'm just going to make a note. It's half as quick. I feel like that's all I need to really write to myself as I plan to make this graph in the future. Then we have 3 next to that cosine. And what this, I realized I just made sine on that graph, but the question is cosine. It still is the same concept. It would still move like half as quick, etc. But I'll keep that in mind as I do future ones. And this 3, when it's multiplied with the cosine, this would be a vertical stretch. When it's getting multiplied, it is vertical. And this vertical stretch, it pretty much decides how tall the graph will go. So if I draw a normal cosine of x, 1, 2, 3, 1, 2, 3, it would start at the 1, it would go down, make our 4 notches real quick, it would go down to 0, to -1, to 0, back up to 1. It would go sort of in crane motion, if you want to think about it, like this guy. He has his wings like that. He's a bird. I'm very good at drawing, by the way. But we also have this graph where it goes up and down to 3. We'll label those final numbers. We have 3 cosine of x. This means it will start at 3. It'll go down to 0, then to -3, then to 0, back up to 3. So we see it's the same graph, it's just stretched out a bit more. Instead of going 1 to -1, it goes 3 to -3. So for the vertical stretch, I would start note that it's 3 times as big for the height. And then with this plus 5, when it's outside when we have a adding or subtracting number outside the parentheses, that means we're having a vertical shift. Vertical shift. This shift, so we have cosine of x right here, but on the other hand, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, just to give perspective. If we have cosine of x plus 5, or 5 plus cosine x, either way it works the exact same way. We have 4 notches at the bottom. We would essentially just move the graph up 5. So it would start at 5. Well, it would actually start at 6, because I forgot it starts at 1. So it would start at 6. It would go down to 5. And then it would go down to 4. Then back up to 5. Then back up. So I did a bit of a bad job making that curvy. But essentially, while we have our 0 being sort of right here, we move that 0 up to 5. That's what it's basically saying. So, the vertical shift, our 0 line, you could say, is going to be equal to 5. And now we have all the components we need to start working on how we graph this problem. So, I'm going to start by at least going up to 5, since our 0 line is at 5. 1, 2, 3, 4, 5. I probably need to be a little taller anyway. So, we're going to start. That's not where we start actually, because cosine will start at its peak. So, and we see the vertical stretch goes up to 3. So 1, 2, 3. Because remember, in our graph, we had it start at 1 and then it started at 3 when it was 3 cosine. So 1, 2, 3. I'm just going to relate these numbers so I don't get just unfocused. So we start at 8 technically. We start at 8. Then by 5 over 2, we're going to go down to 5. And since we have 3 as our height, but we also need to go 3 down for our lowest point, so 5 minus 3 is 2. We'd go down to around right there. And then we would go up to the 5 again. And then we go back up to 8. But that's not it. That's not all. Because we actually still need to make this 1/2 as quick. We did all the vertical parts. Now it should be really easy to just slow it out. So I wonder if I can... I'm going to erase some work and then remake the graph. So now we have the same graph, but without the graph part. We're going to start this at 8 as usual. And then when we think about half as slow, we realize that pi is going to be where 2 pi is. So 2 pi is going to end at 2, right? And from there, it's just making a connection between these points. It's going really slowly like this. And that is how we make our graph. It's going half as quick, it's going 3 times as big, and it's also been shifted up 5. And now for the final part of this equation, it says to obtain an expression for f inverse of x. So f inverse of x pretty much means we just need to replace the x and the y in our equation, then solve for y once again. So what I mean is that previously we had y equals 5 plus 3 cosine 1/2 x, but everywhere is x, we're going to make it y, everything there's a y, we're going to make it x. So x equals, there's only one y in x here, but sometimes it's more prevalent. And now we're just going to solve for y, make it y equals once more. So we're going to start doing x minus 5, because minus 5 both sides, that removes that addition right there. Then we're going to divide by 3 on both sides. X minus 5 over 3 equals cosine of 1/2 y. Then we're going to take the inverse cosine on both sides. And we have x minus 5 over 3, that's all getting that cosine right there, equals 1/2 y. And this fraction, we can almost view 1/2 y as y over 2. So we're just going to multiply by 2 on both sides. And that's inverse. We have x minus 5 over 3 equals y. But remember, this doesn't equal y exactly, this equals the f inverse of x. So as our final answer, we should have f inverse of x equals 2 cosine negative x, negative 1, then x minus 5 over 3. I've seen in the mark scheme before that they will potentially remove points if you write y in the end. So it's just best to write that inverse of x just to make sure they know what you're talking about. Oh, and I just realized I skipped part I, because like, I guess I just really don't like words, so I'm like, ooh, that has words, I'm not gonna do it, but we need to explain why f has an inverse. And the reason why things have inverses is typically because they're one-to-one functions, or it's always because they're one-to-one functions. So, answering this question, f of x has an inverse because there is no turning point that would make it not one-to-one. And by one-to-one, I mean for one x you get one y and vice versa, one y, one x. For example, this is not the case with a parabola. So let's draw one right now. Just your quadratics. We have x right there, x, etc. We have y, 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 y. And for this graph, while it does generally pass the test if it's a function, it would, if you do the vertical line test, you move that line over, you would see it's always a function. But the moment that we flip that, and pretty much taking the inverse, I won't say it's like flipping, but it's it would be reflecting it, that's a better word, reflecting across that x, y equals x line right there. So essentially, this upwards is going to turn into this, and it does not pass the vertical line test anymore. And that's pretty much what I mean when something doesn't have an inverse. It wouldn't pass as a function anymore. While on the other hand, this graph, we just drew it a bit earlier, and I just deleted it. Wow. But it pretty much went like this. So if we had to reflect it, it's a bit weird to think. I'm not the best at geometry, if I'm being honest. So it would be something like that. I'm not exactly like that, but maybe it would start low and then go up high. But you get the point where it would still pass as a function in the end. And that is why it would have an inverse. If there's no significant turning point, that would make it not a function. And whenever you want to make a parabola into something that does have an inverse, we would just cut it off at the vertex. So we'd have something like this. And then that would, when it's reflected, it would be like this. So it's still, it would be like more curvy like that. So it's still past that line test. Now we have question 2. The function f is defined by f of x is equal to 2x squared minus 6x plus 5 for x is all real numbers. Now part I says to find the set of values for p, which the equation f of x equals p has no real roots. So let's start with just setting f of x equal to p. We see a lot of words, but we're just going to start with that little part right there. So 2x squared minus 6x plus 5 equals p. Already, I'm seeing two variables in one equation. I don't really like that, but there is one specific thing we can do. If we have this quadratic where we have two variables in there, we can use the discriminant. The discriminant is found in the quadratic formula, where negative b plus or minus the square root of b squared minus 4ac over 2a. And the discriminant is just this part right here, the b squared minus 4a. And what you need to know about discriminant is that if discriminant is greater than 0, it has two real roots. For example, if I gave you the square root and all of that was equal to 64, which is a number greater than 0, we'd have positive 8 and we'd have negative 8 as our two answers. On the other hand, if discriminant is equal to 0, it has two repeating solutions or one real solution. I prefer to call it one real, but often it's also called two repeating because the square root of 0 equals 0. There's no positive 0, negative 0, it's just 0. Then there is, and also I should add, the square root of 64 is not generally negative 8, but we have that plus or minus. That's what's making it negative, right? Then if the discriminant is less than 0, they're only imaginary solutions. They're only not real solutions. So let's take that, let's take 9 for example, negative 9, which is less than 0. Negative 9 would break into 3i and negative 3i. You don't have to entirely understand I, but I is equal to the square root of negative 1. So if you have any kind of negative number, square rooted, we would just tag I along at the end to show it's still an imaginary number. It's not a real number. So when we see no real roots, that's what that's meaning. We need to find the ones with only imaginary solutions. So without worrying about all that stuff too far, let's just treat this like a quadratic. Let's get it all equal to 0. So 2x squared minus 6x plus 5 minus p equals 0. Now, in this quadratic equation, we see a, b, and c. When we use the discriminant formula, it would act in the same way. We're going to have a is equal to 2, b equal to negative 6, and c, this time, is 5 minus p. We would do what variable is connected to it. For example, in the original standard form, you could say, it's ax squared plus bx plus c. So anything with x squared would be a, anything with x would be b, anything without x squared or x would be c. And that's how we get p tagged on with c. If we had minus px, it would be b equals negative 6 minus p, but that's not the case. We have it with c at the moment. So we would start with the discriminant for it. So b squared minus 4ac. I always like writing that. It just makes me feel confident with what I'm going to plug in next. We'd have negative 6 squared minus 4a, which is 2, then c, which is 5 minus p. So we have 36 minus 8 times 5 minus p. 36 minus 40 plus 8p. Remember to distribute those negatives over. So 36 minus 40, that's going to be negative 4 plus 8p. And remember, we said our discriminant is less than 0. So we need to remember to tag that along at the end. Ideally, you're doing it the whole way through, but I often forget. So if you forget, it's no issue. Just add it along at the end. So now we need to solve for p. We can add 4 on both sides to make 8p less than 4. Then we can divide 8 on both sides to make p less than 1/2. And that is our final answer right there. Next, we have that the function g is defined by g of x is equal to 2x squared minus 6x plus 5. Quite notably, these are the sort of exact same right there. But we notice the domain is different. We have x is between 0 and 4. And it can also be equal to 0 for that's also important. For this question, we need to express g of x in the form of a times x plus b squared plus c, where a, b, and c are constants, or a, b, and c are numbers. We just need to make sure we don't write a, b, and c in our final answer. And our 3 marks is probably 1 mark for a, 1 mark for b, 1 mark for c, right? This ax, b, blah, 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 that is called completed square form. Maybe get that as first I'm going to rewrite our equation. Well, it's expression actually right now. And we're going to make it as close as we can to what this is. So we see that we have a plus c, so we're going to sort of write our plus 5 over here. It doesn't have any x correlated with it. The a will eventually be distributed to x. The b is being added to the x, so we're just going to toss that part over to the side. The general structure you want to use is that you factor out your a right now, or the number in front of the x squared. So we get x squared, and we also need to factor out that 2 from the negative 6. So we get negative 3x. You should get that. You factor it out by dividing. So this is what we have so far. The plus 5 actually looks really low, so I'm just going to move that closer for our sake. Then this is where we add our plus blanks and minus blanks. So we have x squared minus 3x plus a blank and minus 2 blanks plus 5. The reason why I had to add that 2 there is because we're multiplying 2 plus blanks. So in order to not make random numbers appear out of nowhere, we need to make sure this adds back to 0. For example, if I wanted to add 3 into the equation, I need to add negative 3 for it to be equal to 0. Same way if I do 2 times 3, then I have negative 3. I need to multiply that by 2 to make it equal to 0. That's 6 minus 6 equal to 0. That's why we have to have our plus minus blank and then multiply by 2 in both cases. So we have 2 x, then for this case we would divide by 2 and then square that number. So minus 3 over 2, then we'd square that for that to be 9 over 4, and it's always positive because any number squared is positive. And we'd add 9 over 4 over there. So we would multiply this negative 2 and the 9 over 4. So we get 18 over 4 plus 5. You could manually add these fractions, but like, why would you do that if you have a calculator during the exam? So I'm grabbing my calculator, I'm just adding these together, and I get 1/2. So 2 times x minus 3/2 squared plus 1/2 is our final answer. And we see we have an A, a B, and a C. You can write out A equals 2, B equals that, but I think this is good enough as it is because they clearly see what the numbers are. Our next part of the equation says to find the range of g. The range is the y values. So I'm just going to write that over here. Y values. And we notice over here, you got the domain, which is the x values that are allowed. Sometimes your domain will just be really simple, like x can be all real numbers from 100 billion to negative 100 billion, right? And for this case, I find it to be really helpful in these equations to graph what you're dealing with. So, in this graph, the vertex would be 3/2 comma 1/2. You would flip the sign for the x, but for the y it'd be the same. So I'm just going to go by like that. The x would be about right there. So the y would be about there, going by whole numbers, right? And the number in front of x is a positive number, so it'd be opening upwards. It's a very crude parabola, but it works because we see that the lowest point in general is going to be this 1/2. I just realized I graphed that as if it was negative, but it's actually supposed to be something like this. It doesn't matter too much as long as you just know that this number is going to be the lowest point. So we already know that y is going to be greater than or equal to 1/2. And often we could leave this at here, but we notice this question has 2 marks. So as 2 marks means we need to find something else. Right now we only have one value they can really judge upon, I'd say. And this is because the x values peak at 4 and dip at 0. So we can't have them cross over the x-axis, and we also need to end it around there. And the way that I would figure out what is the true max, you could either A, plug in both these values, or think about this more intuitively, where if 3/2 is the absolute middle of the parabola, 0 is 3/2 away from 3/2, right? That's just 3/2 minus 0. On the other hand, 4 minus 3/2, that would equal 5/2. So with a parabola, it goes up the more and more room it gets for the x, right? So we know that we should go with 4 to find the highest value y can be. Worst case scenario, you plug in both your values, see where it gets you, right? But I'm thinking about if you're taking the exam, this is a timed exam, so it'd be really helpful if you can just know which value to use. But no harm in just using both. So we would have this. I would plug in the 4 right into there. So 2 times 4 minus 3/2 squared plus 1/2. At this point, just plugging it into your calculator. So 4 minus 3/2, I just did that actually, it was 5 over 2 squared times 2 plus 1/2. So 5/2 squared, that'd be 25 over 4 times 2 plus 1/2. 25 over 4 times 2, that'd be 25 over 2 plus 1/2. So 25 over 2 plus 1/2, that'd be 26 over 2, which is equal to 13. So now that we know that y can peak at 13, we would write our final answer as 1/2 is less than or equal to y, which is less than or equal to 13. And we know it goes in this order because 1/2 is less than 13, and you can remove the y and write this as 1/2 is less than or equal to 13. Well, not equal to at that point. And we know this is a true statement. That's why we know we've ordered them correctly up here. I imagine it could be like 1 mark lost if you don't order them in the correct way, or potentially 0 marks because you don't understand the full question. And in this, we also know that it's less than or equal to, or greater than or equal to, because we see up here our domain is less than or equal to. If this could not be 0, could not be 4, we'd still have the same math, but we'd do less than on this side, for example. So now we're on to the function h is defined by h of x is equal to 2x squared minus 6x plus 5, which is the same equation we have been dealing with. A lot of times when these questions are part of the same general question, all this is part of general question 2, they're going to have the same kinds of equations, same general format. For example, some of these, we might set them equal to p, we might set them equal to all this kind of stuff, but still the same general equation, so it's always important to note. And this time, the domain isn't 0 is less than or equal to x, it is k is less than or equal to x, where k is a constant. And we need to state the smallest value of k for which h has an inverse. We see this as 1 mark, so we're probably not supposed to do much math here. So let's think about what makes an inverse. We talked about this a bit in the last question. If you have a parabola like this, well, I mean, that's generally how it looks, yeah. And we have the y over x line where it would be reflected to make that inverse. Our new graph would look like this. Or if I just write that to the right so it's clearer, it'd look like that. And in order for this to still be a function, it must pass the vertical line test, meaning it must not hit a point twice when you draw a vertical line. And we see right there, it does hit the line twice. So in order to change that, all we need to do is cut it off at the vertex. Because you could argue, oh, we could cut off over here, but then we draw another line, and we hit the line twice again. So that's why we need to cut off purely at the vertex. And the last time we noted that the vertex was 3/2, 1/2. So we need to see which one of these numbers we'd actually use. So we see k is less than or equal to x, which is less than or equal to 4. So because k is part of the domain rather than the range, we are going to be using the x value, right? We have x there, we have x there. So k is equal to 3/4, or since this is the smallest value of k, so you say k has to be greater than or equal to 3. Oh, 3/2. I don't know why I wrote fourths. Yeah. K less than or equal to, greater than or equal to 3/2. I'm not doing good at inequality today, but yes, that is going to be our final answer. And next part says, for this value of k, find an expression for the h inverse of x. So the way we do this is by replacing our x values with y and our y values with x. So I want to make an important note here. You are never going to use this ugly quadratic when you do these kinds of questions. You are always going to use the completed square form because it is so much easier to do. For example, in our other one, let's say you decide to plug into the messy quadratic because you thought that was a good idea, which is valid if you do these problems for the first time. But if you're on the exam day and you're writing 2y squared minus 6y plus 5, what are you going to do with that? How are you going to get y by itself? You can factor, sure, but you're going to have y minus something, then y maybe plus something else, and you can't do anything from there. That's why we cannot use the ugly quadratic. We need to use this really nice, simple, we have one variable we're working with, right? Well, we technically have 2 variables, but, one active variable, I'd say. So we're going to erase this little mess right here, erase what we are never, ever going to do, and go back to the pen, and we're going to plug in so first we had y equals 2 times x minus 3/2 squared plus 1/2. And now it is going to be x equals 2y minus, oh, I did not mean to put that 2 inside. 3/2 squared plus 1/2. We're going to subtract 1/2 on both sides. So 1/2, we have 2 times y minus 3/2 squared. I'd recommend dividing by 2 on both sides. So x over 2 minus 1/4 equals y minus 3 over 2 squared. You could technically write 1/2 divided by 2 and make that continue with the x, but that feels so weird and messy, and I don't really like that, so I'm just not going to write it that way. Then we need to square root both sides. So like that, or like that. As we plus or minus square root, we can decide that plus or minus later. So plus or minus x over 2 minus 1/4 equals y minus 3 over 2. We're going to add 3 over 2 on both sides. So plus or minus the square root of x over 2 minus 1/4 plus 3 over 2 equals y. But we still need to figure out how to get rid of that plus or minus. But not exactly get rid of it, but how to shift it into a plus or into a minus. Because pretty much on the AICE exam, leaving this as your final answer will get you 2 out of 3 marks, which 2 out of 3 is pretty good. But if we want to try to get 3 when we can. We want to try to max out when we can. So we said that for this value of k, find an expression for the inverse of h of x. So we know that the domain is 3 over 2 less than or equal to x, which is less than or equal to 4, right? And when you take the inverse of an equation, the previous domain of the OG, so the OG domain, is going to turn into the new range. So now 3 over 2 is less than or equal to y, which is less than or equal to 4. So because we notice only positive values in this range, or rather it goes more towards positive values. For example, if you had negative 1/2 is less than or equal to y, or y is greater than this negative number, that's going towards infinity. If we had to graph that, let me go here, there'd be negative 1/2 right here, y would go up towards those positive numbers. So that would still be a case where y is positive numbers. So for our final answer in here, we are going to, I wonder if I can just erase instead of rewriting it. We're going to erase the negative part and only leave the positive. And since square roots are inherently positive, you can just write square root, right? That's completely correct. And remember, you can potentially lose a mark for writing just equals y. You write equals y because it makes sense in our head, but in the end, you probably should write h of the inverse of h of x, like that. So that's pretty nice. We just got a decent amount of marks from working with the same equation a few times. We got 3, 3, so that's 6. 2, 1, that's 3, and 3, so that's 9. That was 12 marks from the same exact equation. And I should mention, all these questions that I use in my videos are from past AICE exams. So if you can get 12 marks immediately, I think the exams are like 60 or 75, something like that. That's really good. That's like, I want to say third the way to passing. That's really good if you can just max out on some of these points. Then we have the next question, that this diagram shows the graph, the inverse of f of x, where the inverse of f is defined by the inverse of f of x, which equals 1 minus 5x over 2x for x is between 0 and 2, where it can't equal 2. And we need to find an expression for f of x, then state the domain of f. So the way you can find an original equation from an inverse is by taking the inverse of the inverse. It would exactly undo all the things that were done to it. So we originally had y equals 1 minus 5x over 2x, but we're going to replace all those x's with y and all the y's with x's. So x equals 1 minus 5y over 2y. I'm going to multiply by 2y on both sides, get rid of that yucky fraction. So 2yx equals 1 minus 5y. I'm going to add 5y on both sides because we see this really cool thing we can do. If I finish this out, we can factor out y from this. Then we have 2x plus 5 remaining, right? And then we can divide both sides by 2x plus 5. That cancels out right there and moves it towards the other side. So we'd have y is equal to 1 over 2x plus 5. And if you want to take the inverse of this and get back to this original thingy, you can. I don't see why you could, but yes, you could if you wanted to desperately prove, yes, this is how you get the original equation. But now we need to state the domain of f. So when I'm trying to figure out the domain, I know domain is x values, so I know I'm supposed to state the x values of this new equation. We had the previous x values, and I think about it, those previous x values are now our OG equation, or this equation right here. Those are new, or the OG's, y's values. It's sort of weird to think about, like, you went from the inverse to go back to the old one. I've honestly, that's the first question I've seen to ever do that. So If you don't really entirely understand this concept, don't worry about it. It's completely fine. I've never seen it happen. But pretty much, this is our new y value. So our domain affects our y values in the same way we know what our domain is when we know our y. So what I would do is you can try to plug in 0 equals 1/2 to x plus 5. But the thing is, when you get 0, the main way to get 0 is if you have 0 multiply something or 0 in the numerator or something. And the numerator is already set to be 1. So that's going to be really, really difficult to do. You can't really take the inverse of both sides. You can't really do anything. But this 2 is looking good to me. So we're going to take 2, and it'd be less than or equal to. So I'm going to set it as less than or equal to our whole equation. And what I would do first is I would take the -1 exponent on both sides. I wouldn't say take the inverse because that wouldn't be correct, but if you have x to -1, it would turn into 1x, 1 over x like that. So when we do that, we would get 1/2, but we'd also get 2x plus 5. It would bring all that back up to numerator, getting us less fraction-y because we don't really like fractions here. Then we could subtract 5 on both sides, so 1/2 minus 5. It is calculator time. I love calculator time. So 1/2 minus 5 is -9 over 2, which equals 2x. Then we would divide by 2 on both sides. Oh, I forgot I made this an equal sign, but it was less than or equal to. I'm going to make those adjustments real quick. So we see that would be -9 over 4 is less than or equal to x, or to be more professional, you could just write the x in front and make sure the alligator mouth of this operator is going to point towards the x again, right? It's almost like looking at yourself in a mirror. The things wouldn't really change direction, they just shift orientation, if that makes sense. So the small part of that lesson sign is still going to point towards the fraction, and that is our domain right there. Alright, so next part we have part II. The function g is defined by g of x equals 1 over x, for x is greater than or equal to 1. We need to find an expression for f inverse of g of x, giving our answer in the form of ax plus b, where a and b are constants to be found. So we generally want our answer to look like that. So if we have a final answer that looks close to that, it lets us know we're pretty much on spot. So this f inverse of g of x, what this means is we need to get the f of inverse, and well, we need to get g of x first. We need to get g of x and plug what g of x is into the inverse of f of x, which we have the inverse of f of x right here, so it's actually really handy for us. We don't even have to find the extra part. Typically on the AICE exam, I'd say you have to find that extra part, which is annoying, but you know, it just takes just a little bit extra work and you get like a mark or two there, here or there. So g of x is equal to 1 over x. That looks quite simple to me. So we would just take 1 over x and plug it into that equation. 1 minus, I don't want to do small 5. 5 times 1 over x over 2 times 1 over x. Before trying to get these fractions to like undo each other, I would just distribute. So it'd be 5 over x over 2 over x. When we have these fractions divided by fractions, what we do is we multiply by its reciprocal, or it's also called keep, flip, change, or KFC, where we keep this main part right here, we would flip this fraction, and we would change the sign, or pretty much we flip the division sign and we change this fraction, however way you want to phrase it. So we multiply by x up here, we would multiply the 1 and multiply this fraction. So we get 1x, or just x, minus 5 because those fractions would cancel out, and we'd still have 2 in the denominator. And looking back at the answer we're supposed to have, we see the answer we're supposed to have is ax plus b. Well, we could have phrased this as 1/2 x minus 5/2. And we see it's a really weird math thing to explain, but we have a plus sign right there. This plus sign could also be a negative sign because when you're subtracting something, you're pretty much adding the negative version of that. I wouldn't do plus minus. That just looks crazy. And also the ACE examiners know what you mean exactly when you write down this. So that's all you have to write. It's 1/2 x minus 5/2. We have it in the form that they want where there's a number for A, there's a number for B. We're all set. Technically, you could write as x/2. I wouldn't do that. I try to write it the way that they have it. That way you can ensure you're getting all those marks, you know? Now for number 4. Part I says to express x squared minus 2x minus 15 in the form of x plus a squared plus b. That sounds simple enough. We did a problem like that earlier, just completing the square. So let's get right into that. X squared minus 2x minus 15. It says up there, but I prefer to rewrite it. That way I can start from the beginning and get towards the end. There is no number in front of a, and there's also no number right there that would take that place, so that's really good. We can just start with x squared minus 2x plus a blank. I'd prefer to put parentheses. You don't have to, but I'd really prefer to. Minus 15. It just ensures you know what goes with what. And so as first part, we would divide by 2, which is -1. Then we square that number, which is 1. -1 minus 15. That is going to be -16, like that. And boom, we have completed the square. And in case we wanted to write it, the vertex is 1, -16. You don't necessarily have to write it, but like while it's on your mind, you can just write that out real quick. That way you don't get stressed later on if you have to write it, you know? Then we have next part of the equation, next part of the question, which says the function f is defined for p is less than or equal to x or less than or equal to q, where p and q are positive constants. They never really say that too much. I'm going to underline that, positive constants. Along with underlying, that's what our domain is. By f of x is x squared minus 2x minus 15. Okay, that's the exact same thing we just had, so we don't have to worry about that too much. And the range of f is given by c is less than or equal to f of x less than or equal to d, where c and d are constants. See, that's how we know it's important. We have positive, we don't have a positive word there. But I'm still going to underline that range. We need to find the smallest value of c. This is 1 mark, so it probably isn't going to take too much work. So, because we know that our vertex of this parabola, let me just draw this out. Oh, I should probably draw the xy axis. So, drawing it out, we got x is 1 and our y is a bit down here. And it's going upwards because we didn't have a number in front of x squared that was negative. And we know that this is the lowest point of the parabola. It's the vertex, it's that turning point where it's going upwards forever, right? So we know that c is, well, the smallest value of c is equal to -16. And we know it's also true because our x value is a positive number and it's specified that our p and q had to be positive. So any number in between p and q also has to be positive. Then we have this next one which says that for the case where c equals 9 and d equals 65, we need to find p and q. I'm just going to quickly erase our work, that way it doesn't get in the way too much. Because I noticed this one requires 4 marks, or we're probably going to have a decent amount of space for it. So, the way I would go about this is by having our equation and then plugging in numbers. So what I mean by that is by c can be equal to 9, right? So I'd write 9 equals x squared minus 2x minus 15. And I would get 0 on both sides. Not both sides, I get 0, make it equal to 0. And I would subtract 9 on both sides, so minus 24. Then I would figure out how to add up to -2 while multiplying up to 24. I think of 6 and 4, with it being -6 and +4. So x is equal to 6 and x is equal to -4. And it wants us to find p and q. P and q are positive constants, so we know it cannot be -4. Then for the next one, it says d can be 65. So 65 is equal to x squared minus 2x minus 15. Like any quadratic, we're going to set it equal to 0. So -15 minus 65, so pretty much just 15 plus 65. 0, 1, 80, so that's -80 right there. And when you think about numbers that would multiply into 80 while adding up to -2, now I think of 8 and 10. So 0 equals x minus 10 and x plus 8, because I'll still add to -2, I'm multiplying to -80. So when we multiply this out, we would get x equals 10 and x equals -8. P and Q have to be positive, so we know it's not -8. So we know x is 6, x is 10, but we're not done because we need to find which one's P and which one's Q. That's probably where your final mark comes in. So we know that it goes in the form that P is less than or equal to x or less than or equal to Q. So I would put that in that order, where 6 is less than or equal to x, which is less than or equal to 10. And we know that is definitely a true statement because 6 is less than 10, right? We know that's true, so it has to be in this order. But also, when I was looking at the mark scheme for this question, there's probably like a simpler way to do it. This is the way I did it originally when I was solving, but they have another format they use, and I want to show you that really quick because, you know, it's always helpful to just have different perspectives on math. So we have that C can be 9 or 65, so we're going to set 9 is less than or equal to our f of x. And we're going to do the complete square form. I know I erased that, but it was x minus 1 squared minus 16. Oh, I wasn't supposed to put parentheses right there. And that's going to be less than or equal to 65, because that's the order it has it for the range right there, right? And we're going to solve both of these inequalities at the same time. We're going to add 16 on both sides. Well, all three sides, I suppose. It's plus 16, plus 16, plus 16. 9 plus 16, that's going to be 25. 25 is less than or equal to x minus 1 squared. It's less than or equal to 65 plus 16, which is 81. The square root of both of those is 5 less than or equal to x minus 1 less than or equal to 9. We know these have to be positive numbers because it says they're positive constants. If not, we'd have to separate it into positive and negative and figure out which one we had to go with. And now we have to add 1 on both sides. So 6 less than or equal to x, less than or equal to 10. And that is what we got last time. So if that's an easier way to do it, I think it is an easier way, but for me it was definitely less intuitive. Do with it whichever way you like. Both ways are correct and both ways will get you all of the marks. And now the next part says to find an expression for the inverse of f of x. So I'm just going to get my pen out now. And the way you find the inverse is by switching the y's and the x's. So we'll start with that. I erased our complete square form, but it was that y is equal to x minus 1. See, during the exam you won't have to erase your answer, so you'll still have these final things. And it's just like, I don't want to scroll endlessly. I still want to have the question present at all times so we can see what all the parts of the question are, how they progress. And we want to switch these x and the y out. We never, ever, ever use quadratic. We always use complete square. Say it 3 times to yourself. Make sure you remember that, because if you don't, you're going to get the wrong answer. You're going to overthink when this actually isn't the worst kind of problem when you think about it. It's a decent problem you'll see pretty often, so it's pretty good to get the hang of it. We're going to add 16 on both sides. X plus 16 equals y minus 1 squared. We're going to square root both sides. That's x plus 16 equals y minus 1. That's a plus or minus square root. We'll figure that out later. Then we're going to add plus 1 on both sides. So plus 1 equals y. And this is where we figure out if it's a plus or a minus. And try to figure this out right now. So our previous domain is going to be our new range. And our previous domain was 6 is less than or equal to x, which is less than or equal to 10. And if now our y is between those, we know y has to be a positive number. So it's going to be the positive version of this, where it's x plus 16 plus 1, or 1 plus all that, doesn't matter what you do, equals not just y, but the inverse of f of x. Just like that. And now our last question. The function f of x is equal to 6 minus 4 cosine 1 half x is defined for 0 is less than or equal to x, which is less than or equal to 2 pi. So it's important to note that we are in radians right now for our domain. We need to find the exact value of x for which f of x equals 4. So we're going to start with just that, f of x equals 4. 4 equals 6 minus 4 cosine 1 half x. So I'm going to start with subtracting 6 on both sides. We get negative 2 equals negative 4 cosine 1 half x. And then we can divide by negative 4 on both sides. We get 1 half is equal to cosine of 1 half x. So then we'd get the inverse cosine of both sides. And we write the rest in. So in our calculator, we make sure we're in radians, and then we do the inverse cosine of 1 over 2. And then equals 1.047, which if we use a button that makes our decimals into fractions, we would see that's pi over 3. So pi over 3 equals 1 half x. So we can multiply it by 2 on both sides. So we get 2 pi over 3 is equal to x. And that is the exact value of x. That word exact means the exact. So we aren't going to simplify this into decimals. That's why I pressed the button to make it into a fraction, because I felt like it was going to be a pretty messy number that could be then simplified by my calculator. Next, we have to state the range of f. The range, as you can remember, is our y values. And the way I would do this is by sketching this whole graph out, because I don't know about you, I can't really visualize what this whole graph means. Maybe it's because I'm new to cosine myself. It's much easier for me to visualize it. And you're absolutely welcome to do that. And I noticed that part III says to sketch the graph. So we can knock about 2 birds with 1 stone. And write this out. We see it goes to negative 4. So I'm going to go down to 4. That's negative 4 right there. But I'm also going to go up. 1, 2, 3, 4. I also see the 6 here, which means you're going up 6. That's a lot. It's a lot. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Because 6 plus 4 is 10. And our sine graph, we have a cosine graph. We do have a cosine graph, but the important part is we have a negative number in front of our cosine. So it's going to make it sort of look like sine because it has a negative value. It's really weird to think about until you plug it into your calculator and you start getting some values, right? So I'm going to start, I would start at negative 4, but we do have that plus 6. So I'm going to be starting at 2, just like that. And I am going to go up to, maybe little notches down here. It's pi over 2. It's pi. It's 3 pi over 2. It's 2 pi. I'm using pi because it has that in the domain right there. Pretty much what we do. Also notice we have 1 half x. That means this graph's going to be 1 half as slow as it usually would. Half the speed it usually would. So we're going to start right here. And I just want to note a general cosine graph is supposed to look like like a bird with its wings up. But we're starting at a negative value, so it would look like Or we're shifting it up, so it'd be And for our final do's, it would be the 1 half speed, which would be pretty much cutting it off right there. If that makes sense. So we're going to start at this middle value of the 2. Then we're going to pretty much go up to 10 for the last bout. We're going to go Make this as curvy as you can. Ooh, right there. I'd recommend writing these mid values. For example, where it goes into pi, that should be going to 6. So 9, 8, 7, 6. And you can just draw these little guiding lines. That way the AICE examiners know what you're trying to do. And this starts at 2. So in this question, we now see that the range of f would be from 2 to 10. I will admit, this question was a little tricky with this one That's probably why parts of these questions have 2 marks and 2 marks again, because this -4 is really going to throw off some people. It just means you start at -4 and you have to go up from there. It's a really weird idea to think about, but once you play around with it, you get a little bit more used to it. If you're really struggling with the subject, I recommend going to desmos.com. They have a graphing calculator where you can plug in these equations and it would show you what that graph would look like. So our y values, we see the graph is lowest when it's at 2. So 2 is less than or equal to y, which is less than or equal to 10, as at 10 is where we hit our peak. So that's the answer for part II. And for the last part, we have part 4, or part IV, where we need to find an expression for the inverse of f of x. We've done inverse so many times, we can do this for sure. We previously had y equals 6 minus 4 cosine of 1/2 x. And when we have inverse, we switch the y and the x with each other. So we have x equals 6 minus 4 cosine times 1/2 y. So we're just going to start just getting stuff to the other side. We're going to start with x minus 6. It's almost like the exact previous question we had, but we're just going to leave it in messy variable form. Then we're going to divide all this by -4. X minus 6 over -4 equals cosine of 1/2 y. We're going to take the inverse cosine on both sides, so the inverse cosine of x minus 6 over -4 equals 1/2 y. Then we're going to multiply by 2 on both sides. So we have 2 cosine -1, or the inverse cosine, x minus 6 over -4 equals y. And make sure for your final thing, you write inverse of f of x. I think you can, well, that's not the inverse of x. It'd be f to the power of -1 of x. Another way I believe you can write this is y to the power of -1. I'm not sure if that part is correct because y is a variable. That's just a vague idea I have in my head. So if you forget this, you might be able to write that, but I am not completely sure. So don't rely on that as if it's God's word. Just I would always go with the f of the power of -1, which is right there in your exam. So it's really helpful. Just go with what they write there. And that's the end of the video. I really hope you enjoyed. I hope this helped you. I don't know if you enjoyed the video, that's the right word. Thank you for studying some math with me. I'll see you next time. Let me know down in the comments if you want to see certain chapters, certain kinds of problems. I can always follow suggestions, and I'll see you next time. Bye-bye.